Good morning. This is section 12.4, and we are talking about circles and angles, so specifically angle measures and segment lengths. This was an activity that we did in class yesterday, and if you recall, we paired up these formulas with these different images, and we also identified some vocabulary terms. So these are the items that you'll need to apply in some practice activities today. So let's take a look at the types of problems that you'll see when you do your Math Excel assignment for today. So actually, if you just flip over to the back of your additional vocabulary support, we're going to walk through some of these examples to hopefully get you prepared to think about, again, those Math Excel questions. So starting with number 1. So some of these you'll need some extra paper, so have your notebook handy. So for number 1, I want you to think about which one of these matches up with number 1. So let's take a look. You can see here I have two that look like they have chords crossing through the middle of the circle. Not exactly the middle, but through the circle. So which one of these are we looking at? Well, to me, I noticed this angle piece here. That's what we're trying to figure out, is the angle measure, which this one does not have. So I want you to actually write next to this a number 2. So we can know which formula we're working with. I think that's the hardest part, is just figuring out which formula to use. Once you know the formula and you can identify the pieces, it's not that bad. So, according to number 2, the measure of angle 1, so in this case, x would be angle 1, is going to be equal to 1/2 the sum of these two arc marks, or arcs. That's just basically saying we're going to take the average of these two arc lengths, and that would give us the measure of angle 1. So we can set that up by saying, okay, so x is going to equal 1/2 the sum of 86 and 88. And maybe you add that up and divide by 2, multiply by 1/2, or maybe you just realize that the average of 86 and 88 is 87. So number 1, x is 87. That looks like it pretty much fits on the paper. Kind of block these out a little bit. It's hard to really have space to do all your work, but some of them we can make it work. Now question number 2, we have to identify. So I see this column right here has similar images to question number 2. Now the key features here would be this angle here is what we're looking for, and I have these two arcs that are intercepted by angle x. So let's look. Let's see. Here's an angle, but it's talking about lengths of this secant here. So here we go. This is the one. So number 7 is what we'll apply in question number 2. So number 7 says we're actually just going to find this angle measure, take half of the difference of these two. So 1/2, and notice that we're going to subtract the larger and then subtract the smaller from the larger. So to do this one, to find x, 1/2, 90 minus 20. Okay, so that's going to be, well, 90 minus 20, that is 70. A lot of this math you can do in your head without getting out your calculator. Half of 70 is 35. So 35 degrees. And we go back and we say, does that make sense? Does that look about like a 35-degree angle? Yes, we're good. Number 3, okay, this one's a little different than the previous question. And which one does it match up with? Well, let's see. Again, it says we've got this angle, we've got this intercepted arc, and this intercepted arc. So maybe it is a lot like number 2. Is there anything else that would possibly look like that one? And my answer is no. So it looks slightly different because you can see we have this line right here is called a tangent. It hits at exactly 1 point. So we need to kind of recognize the versatility of number 7. So it is, this also applies if we have a tangent value. So even if we have this circle here where we have, like we have in this picture, here's a secant and then there's a tangent as well. So number 7 applies to this case as well, which is x equals half the difference of the larger minus the smaller. 150 minus 60, hopefully you did that in your head. Half of 90 is 45. 45 degrees. Hopefully you're finding this not to be quite as intimidating as it initially looks. So number 4, okay, so number 4 we have an angle here, and we have this, we have an angle out here formed by 2 tangents, and it's intercepting this x value here. So that one actually is associated with number 1. So again, there are different images that you can think about in association with this formula right here. Now, the tricky part about this, sorry, that's not the right one. We have an angle here, and we have an arc here. So maybe it looks, again, more like a number 7, because if we look at number 1, you can see it's talking about the measure of that segment, which we don't have measures of segments. So it can be tricky to figure out which is which, but if you really focus in on do I have segments or angles, you can narrow it down. Both of these two, though they look similar, associate with segment lengths. Number 7 is the one that associates with angles and arc marks. The only thing we don't have is this outer arc length. But we can determine that algebraically by saying, since the whole thing is 360 and this is x, well, we know then that this part of the circle would be 360 minus x. And now you can kind of see a more, maybe a longer algebraic equation that's about to form here. So this is where you'll need to use some notebook paper that you can attach to turn this in. So number 4, we'll use that same formula. So the formula says the measure of angle 1, that's that angle there, is going to be half the difference of the larger arc. We call that x minus y. So we'll substitute in 60. We'll substitute in the larger is 360 minus x, and the smaller is x. So this is what we substitute in for this first arc, minus x, which is this smaller arc length. All right, so now to solve. Hopefully this is not too intimidating. We just combine like terms. A minus x and a minus x is a minus 2x. And then we could distribute the 1/2, or we could multiply both sides by 2. Either way, this works out nicely to divide by or to multiply by 1/2. So 360 times 1/2. Hopefully that one's pretty familiar. 1/2 of 2x is 1x, so it's just minus x. All right. So what I see here is I'd like to add x to both sides and subtract 60 from both sides. And subtract 60. So then my next line would look like x equals 180 minus 60 is 120. So there you have it. There's question number 4. It takes way too much space to fit right here in this space. The thing that you might be inclined to think is that, well, we could just double 60 and we'll get 120, but that is not the case. That just was coincidence in this question. You'll see other questions like it where that is not the case. So for number 5, we move on. I have an arc length here, I have an angle here, and I have an arc length here. So again, we're kind of hanging out here at that question number 7 from our additional vocab support. We're still dealing with arc marks and angle measures formed by secants or tangents. So again, hopefully this one's getting in your head by now. This time we have 140, we have x. So we could label this exterior, not exterior, this intercepted arc measure here as 360 minus the sum of 140 and x. So just to find this green arc here, I'm just going to put a little green arc here, is going to be equal to 360 minus 140 plus x. It's kind of hard to see, a little too far away. So 360 minus 140 plus x. Now don't forget this minus sign outside of parentheses means you have to distribute. So 360 minus 140 is 220, and then minus x. So little green arc out here is going to be 220 minus x. Now let's apply the theorem. Again, we're going to need a separate sheet of paper for this question. So for question number 5, we have back to our formula here. So our angle measure, we already have that, is 38 degrees, is going to be equal to half the difference of the bigger. We did a little algebra to figure out the bigger is 220 minus x, bigger arc minus the smaller arc. And then we proceed with some basic algebra here. 220 minus x minus x. Oops. 220 minus 2x. So 38 equals, again, I find it simple enough to distribute that 1/2. So half of 220 is 110. Half of 2x is just x. This works either way. So in this last problem, I added the x to both sides and then subtracted the 60. If you prefer, you could subtract the 110 from both sides. So you got to do 38 minus 110. We get negative 72 equals negative x. And now if we think about dividing by negative 1, x equals 72. All right, number 6. Again, we have an angle measure. Sorry, that's an arc right there, that guy. And another arc. And it's really small, but you can see since these two lines not bisect, but are perpendicular to one another, this little tiny spot here that is our angle measure is supplementary to this. They marked it the right angle here. So our angle measure in number 6 is 90. Okay, so that's going to be a 90 equals half the difference of x and 6. Oh, this one's a little bit easier maybe, but still I think I need some extra space. So let's do that on our separate sheet of paper here. So 90 equals 1/2 x minus 6. Now this is where I pull out I don't really want to distribute a 1/2 to an x because that doesn't work out that well. So in this case, I'm going to multiply both sides by 2. Right? Both accomplish the same task. If you decided to distribute that 1/2 and get a half x and go from there, that's fine. This way I get to eliminate using as many fractions. 2 times 90 is 180. Now we just have the x minus 6 since we canceled out that 1/2. Add 6 to both sides. So 186 equals x. Does that make sense? Let's look at this picture again. Well, 180 would be half the circle, and we're dealing with this measure here, does that look like that's over half the circle? Just over half the circle, really. Pretty close. Yep, makes sense. All right, so hopefully this gets you a start on the types of questions that you'll be asked to do today in Math Excel.